All right, Math Bestie, let's do this. So I'm going to go ahead and teach you this stuff. Which video is this going to take over? I think this is going to do, will I be able to do 13? I don't know. I don't know what video I'm going to do yet. We'll see what happens. I'm going to start with some basics though. Before I can get into this, I need to show you some things. Now, I recommend writing this in your notebook so you have this, okay? Here is, and I'd write this entire thing down. Wait till I make it pretty first, because you know my handwriting's not pretty. I'm going to go ahead and I'm going to write this out. I'm going to write the parent function for square root of x, the square root function, the natural square root. Here's what you don't know. When we have this, there are actually invisible numbers in the parent function. Are you ready? Of course, math always has invisible numbers. Why do we have those invisible numbers? Well, check out my handwriting. We want to get rid of as much handwriting as possible in math because it's people like me doing it. There's a hidden 2 here. This 2 says, hey, you're taking the square root. Up here, there's a hidden exponent right here. When there's no exponent on a value of any kind, a variable, a constant, whatever, the actual exponent is a 1. So, how does this pertain to what we're doing? Because you have to know the relationship between the exponents and the radicals. What's the radicals? These things I call the house. Check it out. What did you see? When I write square root of x, there's actually an invisible 2, there's actually an invisible 1, and it rewrites like this. X to the 1/2 is the same thing as this right here, the square root of x to the 1. You could ask, Mister, why do they have this? Girl, I'm not really a mathematician. I'm a math teacher, so I'm not that great at some of this, but I can tell you this notation helps sometimes, and the fractions help other times. It's as simple as that. The different notation helps us do different things. So I'm going to give you another example of how this works. So you see I have this cube root of x squared right there. How does this translate into, actually, let me move that over. I'm going to move it over right here. So I'm going to write this here. I have my cubed root of x squared. What would that look like in terms of exponents? In terms of fractions, it looks like this. This is how it looks. Master this. Understand the relationship. The numerator is going to be the exponent in here. The denominator right here is going to be whatever the radical has. So in this case, this is the cubed root. So make sure you get that mastered. So now that we have this, you need to understand how this works. So I'm going to take number 13. I'm going to switch ink, and I'm going to go ahead and switch to blue because that's what I'm feeling. Do we have other colors? I'm tired of these. Ooh, we got pink. Can you see pink? Yes. Okay. So I'm going to go ahead and look at this. There's another way that this rewrites as well too. So the reason why this is important is because this is how my brain works. I'm going to do one more over here. Are you ready? There's one more how this actually works. I do not love this notation. I'm going to tell you that right now. It is not my favorite notation whatsoever. But I have to teach it because it's what we use. I get why we use it, but I don't love it. But it is very helpful for us. So with that said, how does this rearrange? I'm doing this wrong. No, I'm not. Here we go. It arranges like this. I'm going to get my cubed root again. My cubed root. This is the other aspect of how these work. This top row, row A, these are all the same things, different ways of writing it. Row B, right here, these are all the same ways of writing the same thing down here. So now you know. This is what it looks like. And if you don't believe me, I'm going to take you to Desmos real quick and show you something. I was going to take you to Desmos, but instead I'm going to do it this way. So what am I going to do? I'm going to find a good number. What's a good number? X squared cube root. Ooh, I don't know. It says, well, let me find the good numbers. Hang on one second. We are going to use Desmos easier. Here's the example I just found. So check it out. If I were to use one notation where I have the cube root right there, and then I took the cube root of 27, and then I squared that whole thing, you'd end up with 9. But look at what this one says. This one says take the cube root of 27 squared. It's bizarre, but it doesn't fully matter what order you do. Don't quote me on that. Let me show you what I mean by that. What is 27 squared? You ready? 27 squared is 729. So when I take the cube root of 729, what do you see? So can you see how taking the cube root of 27 gives me 3, squaring it gives me 9. If I took 27 squared, I'd end up with 729. And if I took the cube root of that, I'd end up with 9. So do you see how order kind of matters. It doesn't. It depends on what you're working on. Don't quote me. But these all do the same thing. You will need the different notation for different reasons. So this and this do the same thing. We use this notation quite a bit. We use this notation as well too. So understand they can give the same answer, even if it's the different order. This one is taking the cube root first, which gives me 3, and then it's squaring it. So it's not that crazy. Do your best playing around with it. You can find some other numbers as well too that might help you. What's a good cube? What's 16? No, 30. What is a good one? 32. No, why am I being dumb? I feel like I'm being dumb. A little bit. It's midday. What's a good number I can put in here? What's a good cube root? 8. Boom. If I took the cube root of 8, it would be 2. And if I squared it, you'd get 4. Well, check out over here. 8 squared is 64. 8 squared is 64. And what do I get with the cube root? 4. So I would practice this. If this doesn't make sense to you, I understand it wasn't that good of an explanation. But these are all doing the same thing. They're all doing the same thing, a little bit of different orders. So let's go back over here and see what we're going to do next. All right. So now here we go. Now what we're going to do is we're going to go ahead and take a look at this 13 right here. I'm going to write down 13 and we're going to see what it wants from us. It wants us to take the cube root of 6r squared. All it wants us to do is rearrange that into exponential form. Exponential form. That means exponent. This is exponential form right here. So how am I going to do this? Watch how I do this. The entire thing, 6 to the r. We need the entire thing in parentheses. If you don't have parentheses around this, you're not doing it correctly. And remember the order. The denominator is located inside the radical, and then the exponent goes in the numerator. And there you have it. That's all you want for 13 through 16. So I'm going to go ahead and work these. I push pause. I don't want you to do the answers. Push pause and try to do them without my help. This one says, what is this? 5, 3n. Am I doing this right? Hopefully I'm reading it correctly. So push pause. Don't show the answers yet. Now, how do I rewrite this? Is that a 3 or a 2 right there? Girl, I cannot see. I think that's a 3. Hopefully it's a 3. That's an ugly 3. How do you rewrite this? Parentheses. And then this right here is in the numerator. And this right here, this number here, is in the denominator. So the answer to 15, what's the hidden number right here? The hidden number is 2 right there. So for 15, you end up with this. 3 over 2. With 16, you end up with, let's see, there's a 2 here. And remember the hidden exponent that's not there is 1. Check out this one right here. So for 16, the answer comes out to, do not forget your parentheses. It comes out to 1 over 2. So master that. That's a language skill. That is not a math skill. So make sure you master that. I'm going to upload this and send this to you. And I'm going to do the next section as well too.